A wonderful good morning, everyone. I welcome you to my YouTube channel. Uh, Today, I bring you another tutorial, which happens to be your tutorial sheet 1 in mathematics, and hope you'll be able to learn something even as we solve these multiple questions under set theorem. So to those of you that have not yet subscribed to my YouTube channel, make sure that you do subscribe and you hit the like button. Also, don't forget to share to those who do not know about this channel. So I'm going to do these questions and hope you'll be able to learn something even as I solve. Now, uh, those of you that who have questions, make sure that you inbox me on this WhatsApp line and I'll be able to respond to you. Okay, so we have the first question. The first question is simply saying, given that U is that set, okay, that is the universal set, then they are saying that X is this set which is made up of even numbers in U. Then they are saying that Y is simply a set of prime numbers in U, and Z is a set, this set that we have been given. Then we have been told to perform the following operations on this particular question. Okay, so I'm going to do the solutions from here and hope you'll be able to grasp what I'm going to teach. Okay, so we start. Okay. So now we have been told that we're doing the first question. Okay. We have been told that U is this set with the universal. We have -2, we have -1, we have 0, we have 1, we have 2, then we have 3, we have 4, we have 5, we have 6, we have 7. Okay, this is the universal set. Then we have been told that X is simply a set of even numbers in U. Now the even numbers in U are simply 2, 4, and 6. Okay, these are the even numbers in U. Now we have been told also that Y is simply a set of prime numbers in U. Now prime numbers are those numbers that are divisible by 1 and itself. So we only have a 2, we have a 3, we have a 5, and a 7. These are the prime numbers. Now, we have also been told that Z is simply some set where we have -2, we have a 3, we have a 5, we have a 6, like this. Okay? Now, the first question is saying we find X union Y. Now, X union Y, a union set, when we say union, we are simply saying unite. So we are going to unite whatsoever element which is in X with those elements which are in Y. We put them together. So therefore, this particular set is going to be like this. We're going to have a 2, a 3, a 4, a 5, a 6, and a 7. That is the answer to this question. Okay. We go to B. B is saying we find a set of X intersection Y complement. Now we know that from BODMAS we start with whatsoever is in the brackets. So we can first of all solve whatever is in the brackets. So we are going to have something like X intersection Y. First of all, we find this. Now X intersection Y, we're going to find where X and Y are intersecting. Now X and Y are intersecting at some point 2. So we're going to have a 2 like this. Now we find the complement. Complement simply means outside of. In other words, we are going to remove 2 from the universal, and whatever we are going to remain with is the complement. So we are going to remain with some value of -2, -1, 0, 1, 3, 4, 5, 6, 7. It's quite simple. Very, very simple. Okay, so this is how you do this operation, this set operation. We get to C. Now C is saying that we find X intersection open bracket Y slash Z. Now Y slash Z can also be interpreted as Y intersection Z complement. Okay, so I'm going to explain what this means. Now, we first of all work out what is in the brackets. So now, Y slash Z or Y intersection Z complement, this simply means that we get all the values that are in Y which are not in Z. So this simply means that Y slash Z is simply the set. We go back to what we listed. So what is in Y which is not in Z? So we have a 2. In Y we have a 2. Okay. In Y we do have a 2. So we are going to list a 2 here. Okay. In Y 3, 3, there is 3 there. 5, 5, there is 5 there. 7, there is no 7 there. So we are also going to have a 7 here. Like this. Okay. Now they are saying that we intersect this particular set with whatever we are going to find in the brackets, like this. Now, in X, we have a 2. There we have a 2. Therefore, our final answer is going to be 2. We have a 7. We have a 7 in. We have a 7 in in this particular bracket. But then in X, we don't have a 7, meaning this is the only number that we are going to find in that particular set. Okay, very simple. Yeah. Then we get to D. Now D is simply saying we find the cardinality of X, union Y. Now X union Y we had already listed in the first place. It's here. X union Y, we had the 2, we had the 3, we had the 4, we had the 5, we had the 6, and the 7. Now cardinality simply means that we count all the numbers that are in here, and that is our final answer. So we have 1, 2, 3, 4, 5, 6. Therefore, our final answer is 6, like this. Okay. So this is how you answer this particular question. We get to the second question. The second question is saying, let R be the universal set and D equal to that set, E equal to that set, F equal to that set, be the subset of X. So now for this question, it's quite simple, but then I'm going to first of all illustrate the information down there. Now they are saying that we can simply lay out the data here. We say the data, okay, the data. Then we can simply say, since some X seems to be the entire set, we can simply say that X, R, which happens to be all real numbers, we can say it's going to move from some point where we have negative infinity to some point where we're going to have positive positive infinity like this. Use these brackets. Okay. Now, according to the information, we have also been told that D is a set which is coming from D is a set which is coming from -7, 4 included. Then E is a set which is coming from 0, 8 like this. Okay. Then F, they are saying that all x values less than 10, such that x is part of all real numbers. So what we are simply saying here is that F is going to be a set coming from -infinity going to some point 10 included. Now the question is simply saying, find the set E/F and display it on the rule line. Now they want us to find, okay, so this is question 2. They want us to find E/F. Now, the best way to solve this question is simply to draw a real line. How do we draw a real line? We are first of all going to draw a line of this kind. I'm going to draw a line of this kind, like this. Okay. Now, I know that this line is simply coming from some point where we have -infinity, and it's going to some point where we're going to have a positive infinity. And then, since the least number that we have to the negative side is simply -7, and we also have a 0 like this, then we also have a 4 here, then we also have 8 here, then we also have 10, something like this. Okay, so it's going to look something like this. Now, I'm going first of all to recognize, since we are finding E/F, so I'm going first of all to draw F. Now, we have been told that F is coming from -infinity up to some point 10 included. So I'm going to put some open circle at -infinity, and I'm going to take this line where 10 is, and I'm going to draw a circle, a dotted circle like that, okay, to show that 10 is included. Okay, then I'm going to label this as F. Then I'm also going to draw E. Now E is coming from 0, so I'm going to draw an open circle here. Then it's going to move to some point where there is 8, like this. So I'm going to draw those two circles. Now I have been taught that, remember what we said in the first place, E/F can also be written as E intersection F complement. So F complement is simply, since this one was dotted, we're going to draw an open circle and take it this side where there is positive infinity and label it this, like this, and also draw a cross circle, since here it was open, and label it like this. Now we are going to ask ourselves, where is this line and these two lines intersecting? You discover that these guys are not intersecting anywhere. Therefore, we can simply state that E/F is simply an empty set. There is nowhere where these two are able to meet. Therefore, it happens to be an empty set. Okay, so this is how you do this particular question. Now we come to B. B is saying, using the sets above, verify that D complement intersection E complement is equal to DU. I'm sure you've seen what's there. Now, this theorem is simply what we are calling as the De Morgan's theorem. Okay, De Morgan's theorem. So they want us to prove that D complement intersection E complement is going to equal to D union E complement. They want us to prove that this particular statement holds, and the best way to prove it is by using De Morgan's law or De Morgan's theorem. So I'm going to use the first concept. So I'm going to draw a line of this kind, like this. Okay, a line like this. Very simple line. Then I'm going to label, this was from negative infinity, this was from positive infinity, this is to positive infinity like this. Then I know that I had the 7 here, which is negative 7. I had some 0, I can label some 0 here. Then I can put a 4 here, I can put an 8 here, and then a 10 here. Then I'm going to paste all the information that I had on this same line. Now, we know that this line here is simply the universal. Now, we are going to put all the information that we had. We'll first of all start with F. Now, we have been told that, which one should I start with? Which one should I start with? I'm going to start with, okay, let me start with whichever. You can start with anything, but I'm going to start with D. Okay, I've chosen D because D is the first one on top there so that I don't confuse you. Now, D is coming from, we have been told that negative 7 is not included because this bracket simply means that it's not included. So I'm going to put negative 7 here. Then I'm going to put an open circle like this. Then I'm going to put a crossed circle here like this. And I'm going to take it like this here. So I'm going to label this one as D. Then I'm going to write E. Now E is coming from 0. So open circle up to 8. Open circle like this. Then I'm going to, okay, label this one as E. Then I'm going to label F. F is coming from negative infinity. And it's going to some point where there is 10. And we can label this one. So we can name this one as F. Now we have been told that according to the theorem, we are going to do the left hand side. Okay, left hand side. So now the left hand side, we have been told that we have D complement, so we're going to do D complement. Now D complement simply means I'm going to draw an open circle here and take this guy, this side, so this is D complement, an open circle here and take this side, this guy, this side. Now you discover that from here up to here, we are going to have something like, the interval is going to come from negative infinity up to negative 7 included, because this was an open circle, so this is going to be included. Yes, okay, I'm sure you've seen what I've done here. So now this is going to be union. Then this is going to come from the point 4 to some point where we're going to have positive infinity like this. Okay, quite simple. Then E complement, we are going to have a cross circle here, moving this side, and we're also going to have a cross circle here, moving this side. So we can name this one as our E complement, E complement. Now E complement is coming from negative infinity to some point where we are going to have a 0 included, union. Remember, there's an open circle, there's a cross circle here. So this is going to be 8, then positive infinity. Now, when you check where these guys are intersecting, you discover that D complement intersection E complement is going to intersect at some point where we are coming from the negative infinity, going to some point where we are going to have a negative 7 included like this. Then union 8 included up to some point where we are going to have a positive infinity. Now, I don't want to waste time because I've shown you how to do the right hand side. If you check, you do the the left hand side. Check, you do the right hand side. you discover that you are going to find the same, this set here. You also find this set. Therefore, we can say that D intersection E complement is equal to what is on the right hand side. Okay, you are going to prove this. So this is how you solve this particular question. Okay, we get to the other question. I'll be very fast. So this one, they are saying for each of the following sets, state whether it is finity or it is infinity. Okay, state whether it is finity or it is infinity. So for the first question, I'm going to do the first one. They are saying this is 3. This is 3. We have A equal to, this is going to be a 0, 1, then intersection R. Now for this one, they are simply saying we find whether it is finity or it is infinity. Now, since these are independent terms, and this is all real numbers, therefore, if we find the intersection of these, the answer is just going to be 0, 1. Okay, therefore we say infinity because we're able to count whatsoever is in there. Get to B. Get to the other question. The other question is simply saying, B is equal to, they're saying B is equal to X other than that's like X to the power 2, X plus 4. Now for this one, you are first of all going to say X to the power 2 less than 4 like this. And you say X to the power 2 minus 4 less than equal to 0. And we can use the difference of 2 squares like this. Then we know that our answers are going to be 2 and 2. If you place these guys on the rule line, you're going to have negative infinity. Put this infinity this side. You're going to have negative 2, 0, and the 42 here. You discover that if you put any value where there is this guy, this thing won't hold because it won't be less than 4. And if you put this number here on this value, it will still be not less than 4. But if you put numbers in between these two guys, you discover that it's going to hold. Therefore, we can say that the only numbers that we have are negative 2, 2. Now, we are using this bracket because we don't know there might be some numbers in between. Therefore, we can say that this set is infinity. Okay? This set is infinity. We get to C. Now, C is saying C is a set of 0, 1 intersection 4 over 3. Now, this is very simple because we know that these are not independent terms. These are also not independent terms. There might be some numbers in between. Okay? So now we know that 0, 1 intersection. If we divide this, we will find 0 point something, comma, so we will find 1 point something, 1 point something. But we don't have any 1 point something in here. Therefore, this is going to be an empty set. But then I taught in my previous video that an empty set is also known to be finity. Therefore, this is a finity. So you can do the rest and do the others. Get to 5. Now for 5, I won't be able to solve this because it's very simple. They're saying which of the sets listed below are equal to each other. Remember, equal sets are said to be equal because they have the same number of elements. These cannot be equal, okay? Because we might have some numbers here, we may also have some numbers in here. But 2 is not included. In here, 2 is included. Therefore, these are not intersecting anywhere. So this is an empty set. There's nothing there. In here, we have a 2, we have a 2. So these 2 are intersecting at 2, okay? These 2 are intersecting at 2. When we come here, these 2 are also intersecting at 2. Have you seen? They're intersecting at 2, okay? these are intersecting at 2. Check these are not intersecting. These are intersecting at 3. So you discover that this guy is this and this, if I'm not mistaken, in this one by explanation, they might be equal. Just do the needful, and then if you find an element, if you find that in here the number of elements we have 1, in here the number of elements we have 1, then those states are equal. But I want to do the last part, at least so that you'll be able to learn something. Now for the last part, which one am I going to do? This one I thought, this one, C. Okay, let me take advantage of C. Now C, they are saying that we prove that square root of 3 plus the root of 2 is irrational. Now the method that we use is called the contradiction